Hello everyone, I am Erica Igana and I will be reporting the next topic, which is about the variations in magnetic declination. So earlier, Ms. Espinosa tackled about magnetic declination. So let's try to recall its definition. So magnetic declination is the direction and amount of variation between the magnetic north and true north. So basically, may nakita duha na version sa north and we call it the magnetic north and true north. Ininaduha na north magkaiba. So from the definition itself, a difference ininaduha amot tinatawag ta na magnetic declination and it only varies by location over time. It can be expressed in degrees east or west. A negative value represents a western declination and a positive value represents an eastern declination. So there are several types of variations in magnetic declination, and these are the daily variation, secular variation, annual variation, and irregular variation. In daily variation, or sometimes we call it as diurnal variation, it is the extreme eastern position of the needle that usually occurs early in the morning, and the extreme western position occurs just about afternoon time. Ang amount hini na declination nagva-vary from 1 minute to about 12 minutes only, haiba-iba na lugar. So, this is greater in high latitudes than near the equator and more in summer than in the winter at the same place. In secular variation naman, its magnetic meridian swings like a pendulum. Do you know what a pendulum is? It looks like a metal ball na nagsiswing back and forth. So the magnetic meridian of secular variation swings like that in one direction for 100 of years, and it gradually stops and then swings again in the opposite direction naman. So this type of variation is slow, gradual, and unexplainable. So walang formula na makakapredict sa variation na to. Next is the annual variation, or also called yearly variation. Ito naman yung change na napoproduce annually ng secular variation, and it amounts in different places from 0 to 12 minutes but does not remain constant at any place. So diri hiya napipirmi sa uusala na lugar. Last is the irregular variation. So these are caused by magnetic storms such as earthquakes or volcanic eruptions. Since any na type of variation nangyayari la pag may magnetic storm, ibig sabihin, dili ta mapipredict kung kakano hiya mag-uukor otro. So an era amount of variation aada laha 1 degree or 2 degree at a time. Let's now move on to isogonic chart. So isogonic chart is a chart that shows magnetic variation with isogonic lines along with its annual rate of change in variation. So as you can see on the chart, it shows the two versions of north and there are also lines that has number of degrees on it. So this line is what we call isogonic lines. These lines are not straight lines. They curve and move, but on aviation charts, they often appear straight. So they are represented in charts by dashed lines and the number of degrees in variation. The lines with zero variation is called agonic lines. Next topic is the use of the compass. So I think everybody is already familiar with compass. This is an instrument that is composed of a suspended magnetic pointer that is attracted to the polarity of the North Pole. This instrument is commonly used for navigation, location, and direction. How are we going to use a compass? First is that the observer sets up the instrument at one end of the line. The compass is held level and the needle screw is released so it will allow the needle to swing freely to its pivot point. A sight is then taken on a point at the other end of the line. So when the needle finally comes at rest, yung magnetic bearing niya will be read by noting kung saan nag-point ang north end ng needle doon sa graduated scale ng compass box. It will be noted sa reading ng compass na yung needle niya will normally and will always points toward the magnetic north kahit na yung compass box and sights are being rotated. Yung north end naman ng needle ay nag-i-indicate sa angular part ng bearing and yung quadrant niya which where the bearing lies is also being determined by observing the markings on the compass box. Bearings are usually read for just about 10 to 15 minutes only, although it is possible to estimate much smaller values. Yung south end naman, which is easily identified by a fine wire coiled around the needle, is only read if it is desired to determine the back bearing of a line or to check the reading on the other end of the line or the other end of the needle. So basically, bearings are read in both directions. Next is local attraction. Local attraction is any deviation of the magnetic needle of a compass from its normal pointing towards magnetic north. Sometimes, the compass user may not realize that the magnetic bearings read with the compass can be affected by the local attraction. In some localities, particularly in cities and in large excavation sites of iron ore deposits and steels, its effects is so pronounced that a magnetic compass could not be reliably employed for determining direction. This means that a local attraction can also affect compass reading, especially when the surroundings are full of steel and iron materials, such as reinforcing bars, power transmission lines, or even a moving vehicle can have a distorting effect on compass reading. So pag nandun tayo sa isang local attraction with that kind of surroundings, yung compass natin will not be reliable in determining directions. Kasi even just a certain amount of magnetic influence, pwede na nitong mag-draw ang needle ng compass palayo sa magnetic meridian. So yung readings natin ay magkakaroon ng same amount of errors dahil sa ganitong klaseng disturbance. However, angles calculated from bearings taken at the point will still be correct. The magnitude of fixed local attraction can still be determined, and magnetic directions may be observed and may be corrected accordingly. But, if a local attraction with a direct current fluctuation, there is no way of determining specific effects. So if you encounter such problem, the best thing to do is to avoid it. Local attraction is present if the two observed directions differ by more than the observational errors. We can also detect a local attraction when the forward and back magnetic bearings of each line are read and at its end. Let us now move on to magnetic dip. The magnetic dip is a characteristic phenomenon of the compass needle to be attracted downward from the horizontal plane due to the Earth's magnetic line force. If viewed in a horizontal projection, the lines of force define the magnetic meridian. Magnetic dip results from the tendency of a magnet to align itself with lines of magnetic field. As you can see on the photo, the magnetic field lines are not parallel to the surface. The lines are inclined downward toward the north in the northern hemisphere or the positive dip, and also downward to the south in the southern hemisphere or the negative dip. Yung lines niya are horizontal lamang sa point na malapit sa magnetic poles and from the halfway point toward the pole. Ang nangyayari ay yung magnetic line of force ay nagiging steep, pero yung pole niya is practically in a vertical position pa rin. Yung purpose of this is to counteract the dip effect para yung needle ng compass ay mag-form into a horizontal position and para makamove na siya freely sa kanyang pivot point. And the counterweight will only be attached into one end. So if the compass is used in the same general vicinity and loses none of its magnetism, hindi na natin kailangan palitan yung counterweight nito. Pero pag ang compass ay ginamit sa more distant na latitude, the weight may have to be shifted accordingly, pero yung needle niya needs to remain in a horizontal position. Let us now move on to compass surveying. Compass surveying is the branch of surveying in which the position of an object is located using angular measurements determined by a compass. This is widely practiced methods of determining the relative location of points where a high degree of precision is not required. Compass surveying is used in following circumstances. It can be used if there is a large area to be surveyed, such as coastal areas or the coastline areas of the river. It can be used if the area is crowded with many details and has many obstacles for conducting chain surveying, as triangulation becomes impossible. It can also be used if the surveyor has a specific time limit for conducting the surveying on a large and detailed area. Let us note that the principle of compass surveying is traversed. So here are different terms which are related to compass traverse. These are the traverse, traversing, traverse station, and traverse lines. First is traverse. It is a series of lines connecting successive points whose length and directions have been determined from field measurements. Next is traversing. This is the process of measuring the lengths and directions of the lines of a traverse for the purpose of locating the position of a certain point. Next is traverse station. It is any temporary or permanent point of reference over which the instrument is set up. It is usually marked by a peg or a hub driven flush with the ground and identified by consecutive letters or numbers as the survey progresses. Lastly is the traverse lines. These are lines connecting traverse stations whose lengths and directions are being determined. So here are some advantages of compass surveys. First, the instruments are easy to use and is less expensive. Second, they are portable and lightweight. Third, they have fewer settings to fix on station. Fourth, the error in direction produced in a single survey line does not affect the other lines. Fifth, it is suitable to retrace old surveys. And lastly, obstacles such as trees and shrubs can be passed readily by offsetting the compass a short distance from the line to be observed. So there are also errors in compass surveying. It can be instrumental errors, personal errors, or nature errors. When we say instrumental errors, these are errors occurred due to the wrong adjustment or by the instrument fault. Personal errors are errors occurred by compass adjustments such as leveling, centering, and fixing, whereas nature errors are errors occurred by local influencing factors such as magnetic field, local attractions, and declination. Now that we have identified what is compass surveying, let's now proceed to its traverse types. Just like what I've said earlier, the principle of compass surveys is traversed. There are only two types of traversing and it's the closed and open traverse. So what is the difference between the two? So closed compass traverse originates at a point of known position and terminates at a point of known position. As you can see in the illustration, this type of traverse forms into a loop simply because it starts and ends at the same point. It consists of series of lines of known lengths and magnetic bearings, and the advantage of using the closed compass traverse is that we can monitor the angular measurements, take bearings, and measure the distances in a particular order. Whereas an open compass traverse originates at a point of known position and terminates at a point of unknown position. So an open compass traverse is run for preliminary exploration purposes in route surveys. It also consists of a series of lines, but these lines are continuous. It does not return in the starting point nor closed upon a point of known position. That is why surveyors has no available checks for arithmetic and the field's measurement of error and mistakes. It cannot also sum up the angles into known geometrical conditions. That is why it requires extra care when making required angular and linear measurements. Adjustment of an open compass traverse. In a compass traverse, there are likely to be discrepancies between the observed forward and back bearings of lines. This may be due to errors of observations or local attraction. Angular observation made for a particular traverse must be thoroughly examined to determine the best method of eliminating the discrepancies without having to make very large adjustments or alterations. So kung mag-a-adjust tayo ng isang open compass traverse, we need to take note these two important steps. First is, kailangan natin i-determine kung saan sa mga linya or station na to ang free from local attraction. Lines that are unaffected or is free from local attraction is what we call the best line. Let us also bear in mind that if there are two or more non-adjoining lines that are free from local attraction, only one of these lines can be considered the best line. The second step is to perform the adjustment of successive lines by starting from either end of the selected line. Now, let's have an example on how are we going to adjust an open compass traverse. Given the tabulation that you can see on your screens, those are the observed forward and back bearings of an open compass traverse. So what we are going to do is to adjust the forward and back bearing of each course. Given the tabulation, there is line AB with a length of 400.63 and a forward bearing from north 25 degree and 45 minutes to east with a back bearing from south 24 degree and 40 minutes to west. Line BC with a length of 450.22 and a forward bearing from south 20 degree and 30 minutes to east and a back bearing from north 20 degree and 25 minutes to west. Line CD with a length of 500.89 and a forward bearing from south 35 degree and 30 minutes to west and a back bearing from north 35 degree and 30 minutes to east. Line DE with a length of 640.46 with a forward bearing from south 75 degree and 30 minutes to east and a back bearing from north 75 degree and 25 minutes to west. Line EF with a length of 545.41 with a forward bearing from north 58 degree and 50 minutes to east and a back bearing from south 58 degrees and 15 minutes to west. Last is line FG with a length of 700.05 with a forward bearing from north 22 degree and 3 minutes to east and a back bearing from south with 21 degree and 55 minutes to west. Now I'm gonna show you a video on how to solve or adjust an open compass traverse. For example, we're gonna have to make an adjustment for line DE. So let's bear in mind na mas madali natin madidetermine ang problem kung i-isolate at i-analyze natin ang each station ng traverse. For this problem, we're gonna have to isolate station D to look for its included value of angle before solving the adjusted bearing of line DE and ED. So, given is the observed bearing from line D to C, which is equals to north 35 degree and 30 minutes to east, and observed bearing of line DE, which is equals to south 75 degree and 30 minutes to east. In order to solve station D, we are going to use this solution. Station D equals to 180 degree minus observed bearing of line DC plus observed bearing of line DE. So, i-substitute tan value sa DC and DE. 180 degree minus the value of line DC, which is 35 degree and 30 minutes, plus the value of line DE, which is 75 degree and 30 minutes. So, we just have to add this two and subtract it to 180 degree. So, it's equals to 69 degree and 0 minutes. So, this is the correct value of the included angle at station D regardless of its local attraction. Now that we have found the correct value of the included angle at station D, let's move on in solving the adjusted bearing of line DE and ED. So, given again is the observed bearing from line D to C, which is equals to north 35 degree and 30 minutes to east, and the correct value of the angle included at station D, which is equals to 69 degree and 0 minutes. So, katulad kanina, let's just substitute the value of DC and station D. So, 180 degree minus 35 degree and 30 minutes plus 69 degree and 0 minutes. So, kakalculate lang natin to just like kanina. Let's just add this two and subtract it to 180 degrees. So, it's equals to 75 degrees and 30 minutes. Therefore, the adjusted forward and back bearing of lines DE and ED is equals to 75 degree and 30 minutes. Let's have another example. This time, ang i-adjust naman natin ay ang line EF. So, continuation nito ng example kanina yung line DE. Lahat ng given sa mga problem na to ay makikita sa tabulation na ipinakita kanina. So, just like the example earlier, we're gonna have to isolate station E to get the included value of angle before solving the adjusted bearing of line EF and FE. So, yung given natin ay Observe angle of line ED is equals to north 75 degree and 25 minutes to west, and observe bearing from line EF is equals to north 58 degree and 50 minutes to east. So for this problem, madali lang ang gagawin natin. We just have to add these two observed bearings to get the value of angle included at station E. So station E, 75 degree and 25 minutes plus 58 degree and 50 minutes. So it is equals to 134 degree and 15 minutes. So this is the value of angle included at station E regardless of its local attraction. Now that we already have the included value of angle at station E, let's now proceed in solving the adjusted bearing of lines EF and FE. So this time, ang gagamitin natin na given for line ED ay yung adjusted bearing na sinolve natin kanina, which is equals to 75 degree and 30 minutes. And of course, the value of station E, which is equals to 134 degree and 15 minutes. So kung kanina inad natin yung dalawang bearings to get the value of station E, ngayon we are just going to subtract these two given to get the adjusted bearing of line EF and FE. So observe bearing EF, station E minus adjusted bearing ED. So 134 degree and 15 minutes minus 75 degree and 30 minutes is equals to 58 degree and 45 minutes. So this is now the adjusted forward and backward bearings of line EF and FE. So you can just follow this procedure, yung example number 2, to adjust all the forward and back bearings of each course given in the tabulation earlier. So that would be all for my report. Let us now move on to the next topic, which will be discussed by the next reporter.